So let's just dive into the super duper quick lesson summarizing what the shell and the washer method and the what, why, and whens of both of these. And let's just jump straight into an example. Starting off with what the washer method is, if I were to summarize it, I'd say that the big idea is just summarizing the outer volume minus the inner volume, which gives us the shaded volume of this. And you can visualize this in like real life nuts, where it's like they have that hole and then there's a metal part, but in order to find the metal part, you subtract the entire volume from the actual hole itself. And in the case of math, what we do is that when we have a function that's revolving around some line, in this case around the y-axis, that we would split up the actual revolved curve into many infinitely thin slices of cylinders. In this case, what we realize is that when the volume of the cylinder equals pi r squared h, that we can say that the total volume would be actually that it's the sum of all of these cylinders from the bounds of a to b with respect to whatever we're writing it with respect to. And in this case, where we'd say that we notice that the height is actually the change in y, and that r has some kind of relationship to x, aka that we have to write it with respect to y, that then we realize that in the example of this, for example, that we have to write it with respect to y. So first things first, what I do is I graph the two curves, and then after splitting up all of these the area of these curves into many thin slices of cylinders, we realize we have to write it with respect to y. Second then that means we have to rewrite our variables. So y equals x squared becomes x equals positive negative root y, and that x equals y. And that part 2 is that we have to actually understand and determine the bounds, which we know is from 0 all the way to the point of intersection, which is at y equals 1 between the x and root positive negative root y, or the y and the positive negative root y. So then after knowing that the outer radius, because this is the furthermost curve, is positive root y, and this is also because we're essentially just exploring the area in the first quadrant that's being revolved around the y-axis, so it's positive, and then we know that our inner radius is y, then we can easily say that the volume of the cylinder is the sum of the outer radius squared minus the inner radius squared, all with respect to dy from the y bounds of 0 to 1, which gives us the answer of pi over 6 units cubed. Let's look at another example then, where we have a curve or function that says y equals 5x cubed plus x squared and y equals x. And it's also revolved around the y-axis. First things first, we graph it as usual, and we notice that, hey, it looks pretty similar to our previous example, which is a funky salad bowl. And then maybe the thing that we would have tried to do is that we would have tried to split this up into infinitely thin slices of cylinders as well, realize that we probably have to write it with respect to y, and that the radius in this case does equal f at y, or at least like the x values of the outer and the inner curve itself. And then we realize a problem, because our outer curve, in this case y equals 5x cubed plus x squared, we realize that we can't actually write it with respect to y because we can't isolate these x variables. So that's the problem, but where the solution comes in is by using the shell method. And how I'd summarize the shell method in one word is by imagining it as layers. And essentially it's just saying that we're going to find the volume using an infinitely thin amount of hollow cylinders that revolve around the line, in this case y-axis, so many thin layers, and then finding the sum of the volume of all of these cylinders, which can be represented by how when you smush one singular hollow cylinder, that it becomes proportional to the volume of a rectangular prism, where length is proportional to the circumference, the height equals upper minus lower bound, and that the width is actually equal to delta x. And what's great about this, in this solution, the shell method, that we don't have to rewrite our variable with respect to anything else than what it was already given to us in. So that's good because we don't know how to rewrite it any other way. So after graphing, we find the POI. We can either set them equal to each other, use our calculator. In this case, the point of intersection is at x equals 0.358. Then at this point, step 3, where we know that essentially the volume of one cylinder is proportional to the rectangular prism, then we can say the total volume is the total sum 2 pi from the x bounds of 0 to 0.358 of the x portion of the L multiplied by the height, all with respect to dx. And that this gives us the total volume of 0.0333463 0.3862 units cubed. To compare the shell and the washer method, I'd say that it's ultimately helpful to use the washer method when it's just more conventional in general, but it's only to be used when your function is already like preset or can be set in terms of like your required variable already. And whereas you can use the shell method for anything, it's less efficient, but it's certainly the best and most helpful solution when we can't really write our variable in terms of the required variable to find volume.